We will now begin Module 1, UHPC Shotcrete, Virginia Department of Transportation Abutment Repairs. We're pleased to introduce our presenter, Sam Valaha, who is currently the Northern Virginia District Bridge Engineer with the Virginia Department of Transportation. Sam was formerly with the Florida Department of Transportation, working with the research group there, and he's also formerly with the Nebraska Department of Transportation. So we welcome Sam. We're also joined by Dr. Aziz Amini, who is with Florida International University. He's the director and a professor. So we welcome you both. I will now turn the presentation over to Sam.
Thank you. Good morning, all. UHPC spray applied application with the Virginia Department of Transportation. Recently, this is the outline of the presentation, but recently I ran into Dr. Azizi at the university, at the TRB. I've known Dr. Azizi for quite a long time, and we had discussion about UHPC, and he introduced the idea of UHPC spray applied, and I'd had a few applications or a few situations where it would be applicable. So I suggested we collaborated, and he agreed, and we started this project. So this project is simply a proof of concept to prove that spray applied UHPC is applicable and is possible and usable. So the outline of the presentation is why UHPC, why spray applied, and then a general idea about the ramp H bridge application, the logistics and how things went, and then lessons learned, how we could improve in the next on the next application and the next project. So why UHPC? UHPC obviously for durability, as Kathy mentioned in the last presentation, that the material is impermeable, preventing chloride intrusion into the concrete and corrosion of the reinforcing steel, and that is essential in many of the repairs that we do. And in this case of abutment repair, the bond of the concrete is important, and UHPC provides a very good bond. And also, although in the case of repairs, in our case, the strength is not critical, but UHPC fits the bill. So the other question is, why spray applied? Thin layer of UHPC, in this case, let's say about 1 inch cover on reinforcing steel, will be adequate. And to apply a form and pour technique, you need to add thickness to the concrete, and quite often you add 4 to 6 inches, and that is really significant weight added on the foundation, and possibly, I guess, the aesthetic may be also a factor. But at the end of the day, it is not necessary. If you could use UHPC, 1 inch is adequate to provide the coverage and spray applied rather than form and pour. The old traditional trowel applied is manual and tedious, and I'm not sure that it's been used in the case of UHPC and may not be usable. However, it should be noted that spray application and spray applied UHPC or any concrete require very skilled nozzlemen to apply the concrete consistently and in the right places at the right time. So it is workmanship sensitive. The location of the bridge that we used is on ramp H, of the interchange of 495 and 50 just west of Washington, D.C. And this is what they call the Beltway. The 495 is the Capital Beltway. And it is heavily traveled or interchange and roadways. So the ramp carries the ramp H traffic of 495 over the US 50 or Route 50 ramp. This is a picture of the location showing the intersecting ramps on the right side, as well as the top of the bridge deck. The bridge was built in 1985. It is it's in good condition. The deck and the superstructure are in good shape and good condition, and rated. The general condition rating is 7. The substructure is in fair condition due to the chloride, and as you can see, that the superstructure is super elevated, so the drainage is going to the right, and that's where the damage is due to the chloride drainage and the leaky joints at the ends of the bridge. So this is the view underside the bridge, and it shows the lower side of the bridge, which is due to the super elevation, showing damage, and you could see the areas highlighted in the boxes. Those are the areas that needed attention. This is a close-up of the damaged area, and you can see that the corrosion of the reinforcing steel has delaminated the concrete, and there's significant areas of concrete that needs attention. Spalls and delamination, and I guess just generally speaking, because the bridge is in good condition, this would be classified as preservation action. So this is the surface preparation, and I guess we removed the delaminated and end-sound concrete, sound blast, water blast to expose aggregate. However, as you could see that some of the steel corrosion remained, was not totally removed. And this may require a little more removal, but at the same time, when you're using UHPC, due to the fact that it does completely seal and prevent any chloride and any oxygen intrusion into the concrete, this may be adequate. And of course, the surface preparation to receive the UHPC should be one is exposed aggregate, and we achieved that. And of course, should be wetted to surface dry condition. So the preparation for the application. The Florida International University, Dr. Azizi brought in with the students and the others, brought in all the UHPC ingredients. They brought in the compressor and the hoses and to apply it. And we provided basically the concrete mixer, the man lift, and I guess the traffic control, which is essential for any application. However, I guess the gist of it is that really the application is possible, and mixing the concrete would be recommended that you prepare the quantities before you arrive at the site, so it's kind of a pre-bagged mixes almost. So to ease and to cut the time short at the site, or to reduce the time needed at site. However, mixing UHPC takes a little bit of time, maybe 30 to 40 minutes. On the right side, you see the picture of applying the concrete, and in that the nozzleman happened to be Dr. Azizi himself, with the help of others. But you could see that they are in the man lift, and they're applying the UHPC to the abutment repair. After the repair, we applied white pigmented sealer to seal the moisture in the concrete in the UHPC. And then we applied wet burlap and plastic to seal it and maintain the moisture for additional curing. In the final finish, in the final finish of the concrete is a little uneven. However, I guess it could be treated for aesthetic, or it could be, if you apply the entire wall, then maybe that is a type of finish. Or if you just repair it, it may require some additional treatment to provide the finish and the aesthetic that you are seeking. So UHPC. The lessons learned from this applications is that one that is not written on the screen is that as a proof of concept, yes, it was proven, and yes, it is possible, and yes, it is practical, as a matter of fact. But the lesson learned is that accurate mix design for consistency. Obviously, like I said, if we can pre-bag the ingredients beforehand, so that the mixing at site is done quickly, or if it is available and possible to have it in a prepared in large quantities and ready mix type of application, that would certainly make it easier and faster application. Mixing at site is complicated, and complicates the site setup. So you need to provide a place for mixing and a way to transfer the concrete to the pump, and of course the pump and the man lift need to be positioned in the right place, and to be applied, or to apply the UHPC properly and comfortably. Obviously, this is hard work, and the ease of the application makes it easier and better to produce a better product. And of course, the aesthetic, this could be either presentable finish, meaning that we either treat the finish with something to smooth it, or apply coating, or apply it to the entire wall to make it consistent, so that it's presentable. And of course, the logistics is that planning is important, and pre-planning is essential. In this case, a mock-up, we tried it on one abutment one evening, and then we tried on the other abutment the other evening. One is to make sure that we have the logistics right, and even then there's still room for improving logistics and planning setup at site. Finally, acknowledgement. The first acknowledgement is to Dr. Azizi at Florida International University and his team for applying this and for the help. They actually drove the truck from Miami all the way to the Washington D.C. area, and they applied it. And Dr. Azizi was the nozzleman, so thank you, I appreciate it. Also like to acknowledge the fact that Virginia Department of Transportation Research Council, the VTRC, Dr. Shelik Ozeltram and Gabrielle, they both helped and assisted, especially Gabrielle, with the testing of the concrete, the UHPC. And of course, the Nova Bridge maintenance team that set up the site and provided the logistic support from Mexer and so on and so forth. With that, I conclude my presentation. Kathy, any question before?
Torin, I think we're going to roll into your presentation now.
Yep, thank you. I'll change it.
Okay.
We will have questions for Sam when Dr. Azizi is complete.
Thank you.
All right, thank you, Sam, for giving I'm gonna stop my camera so that I can see and let me put it back in well, I guess you guys see my slide, right, Kathy? Everything?
Yes, you are good to go.
All right. So anyway, I'm gonna tell you the story of basically the collaboration that we had with the Virginia DOT and with Sam, and in field demonstrating basically the Shotcrete with the UHPC. One of the questions that we've been working at the Shotcrete with the UHPC for some time, and always there's a question that can you do it in the field? And in fact, I believe that there's a publication by the Federal Highway Administration that recently came out, and in the conclusion says that in the field conditions, the contractors have encountered some challenges, and I can see why. So this was the main reason that we decided to also work with one DOT to demonstrate that it is feasible to apply this in the field conditions. So this is a story of what we did. I think I'm going to skip this. These are the definition of the UHPC. Kathy went through it, and so we are using basically definition that is given by the FHWA. Now, we did use the or open source UHPC. At ABC-UTC, we have developed for a number of the years that the open source UHPC, basically, or non-proprietary, other universities have developed this. So we are seeing that more entities are developing this. So the ABC-UTC open source UHPC that we have, the cost of the material is about $500 to $600 per cubic yard. Okay, so this is just the material itself, just the material. This doesn't include the mixing or anything like that, the labor that takes and all that. But if you just look at the cost of the material for ABC-UTC, it's about $500 to $600 per cubic yard. We did use for this Shotcrete, we did use the open source UHPC, but modified version of it specific for the Shotcrete. So it is very important to distinguish. There's an open source ABC-UTC, UHPC, and then there's a modified version of it with some admixture added and some modification for the Shotcrete, and that's what we used. We are conducting, we have a project by the US Army Corps that we are looking at the development of the UHPC for 3D printing, but the Shotcrete actually is included in the 3D printing. And within that project, we are looking at the properties of the UHPC at the fresh state. I won't go too much through this, and also the hardened properties. The hardened properties include the mechanical properties and the durability. Of course, one of the main reasons that why we use basically the UHPC, it's a durability aspect of it. We've been looking at for example, the effect of the steel fibers. In the US, at least we are using 2% by volume steel fibers. I know that my good friend Eugene Bruweiler believes that we have to use it 3.8 or 4%. But I think the 2% that we are using in the US has proven to be giving us a good durability and the mechanical properties. So, but anyway, this plot actually shows the effect of on the flow diameter. You go more than 4%, really, the workability of the UHPC gets really low. We've been looking at the rheological properties of the UHPC, and of course by addition of the steel fibers, when you go from no fiber to 5%, let's say by volume, it takes a lot to really the workability of this material becomes a little more challenging, especially more than a 3% or so. The other thing that we've been looking at, for example, the setting time, and there's a test, penetrometer test, that we utilized to set the initial setting time and the final setting time. So this is important as far as, for example, when you make a mix and how long time do you have to really to work. So we are doing quite a bit of work on the material aspect of it within the project that we have. One of the questions that everybody's asking, in fact, it is one of the questions that was submitted during the registration process. The question is that, how about the bond between what you shotcrete and the normal strength concrete, that the surface that's been shotcreted? There has been a tremendous amount of information available within the FHWA, other researchers, and data that we have developed. Even with the shotcrete, if you prepare the surface correctly, if you prepare it so that you have an exposed aggregate, if you prepare it so that you have basically you wet the surface for adequate amount of time, about 24 hours before the shotcrete, you will get a very good bonding. And in fact, the direct tension test that we have done according to ASTM, in every case, without an exception, the failure is always at the normal strength concrete. The interface, at the interface, you don't get a failure. So that's a fairly good news. We've also been looking at the freeze thaw test, and other people have looked at it. It's a wonderful material. It has even after 365 cycle, others have reported that really the dynamic modulus is not changing. You don't get the mass loss or anything like that. So we've been looking at this. Actually, this is one of the series that we are testing, and even after the 120 cycles, there is no change in the dynamic modulus of elasticity. And we've been testing, doing the freeze thaw on a companion normal strength concrete that we obtained from basically ready mix concrete. And the UHPC, of course, outperforms the normal strength concrete by far. We've been looking at some of the admixture that we've been adding to the open source UHPC, trying to see if that changes the durability. We have not seen anything. Even with the additional admixtures that we are adding for the shotcrete purposes, everything is working fine. The durability and the strength basically are not affected. We've also been taking a core from and conducting a rapid chloride permeability test of the surfaces that have been shotcreted. You can see over here, for example, if I just look at the normal strength concrete with no UHPC shotcreted, we get about, let's say, 1200 coulomb in the RCP test. If I take a normal strength concrete and I add a shotcrete 0.55 inches, the rapid chloride permeability goes down to 300, 0.68, 0.7. So I'm fluctuating between 200 and 400. coulomb, basically. And this is a cast in place. Of course, that's a 2-inch, not 0.55. We are developing some additional. But the story really is that if you add very small amount of the UHPC, the RCP, the coulomb basically gets quite smaller. So basically meaning that the moisture is going to have a very difficult time to penetrate. Now, some people ask, for example, what thickness do I need? Maybe we don't have the data yet, but I think using the basically RCP and using the basically the what you get basically the RCP numbers, I think it's feasible probably to relate that with thickness that you need and the service life that you need to achieve. Now to the Shotcrete in Northern Virginia. I'm going to be going a little bit fast so we have some time for the question and answer period. So we decided in this case to get, because we didn't really have time to do lots of tests with the local material, we decided to get enough material to make a 50 cubic feet, 50 cubic feet, almost 2 cubic yard of UHPC. This included the sand, cement, silica fume, slag, super plasticizer, admixture for the shotcrete. We also took the nozzles and the pump that we have modified it. So the pump, nozzle, hoses, everything, because we wanted to make sure that we've got everything and we are fully knowledgeable. And one of the conclusions that I'm going to make is that UHPC with the Shotcrete is a system. You have to look at it as a system. Every element of it is very important. If you don't pay attention to the details, it's not a difficult process. It's just a system that every element is important. You cannot say one element, nozzle is not important, hose is not important, cleanup is not important, the pumping system is not important. Everything is important. If one element fails, doesn't function, the entire thing. So we had the staff basically, we loaded up, we drove it to the Washington area. It took them to staff about 2 days to go up there. Now we were planning actually on the left-hand side. This is the wall that we were planning to shotcrete, and then we asked for maybe a smaller area to be available for us for practice. On Monday to practice, and then Wednesday to do the shotcrete. The plan when we arrived, the plan changed. Basically, they had another abutment that they wanted us to basically to shotcrete on Wednesday, and then use the one that was supposed to be shotcreted for the final on Wednesday to use that as a practice. So which was fine. The mixer that we had we could only mix 8 cubic feet, which was kind of small. So that means that we had to, for example, the abutment that you see on the right-hand side, we had to make a 2-batch. On the left-hand side, we didn't really have enough material to fill it up. So on Monday, the Sunday, everybody arrived on site. We had the materials. We went to the maintenance yard, and then from there to the job site. 9 o'clock at night, they closed the one lane, and then we started the shotcrete. I'm going to show you some of the shotcrete. This was on the Monday night. As you can see, it is fairly the shotcrete. I know the video is a little bit jerky, okay, but it kind of shows you. Now, I didn't go all the way top. I had the honor of to be the nozzle man in this case. And I wanted to do that. I said, you know, this is a feasibility test. I'm just going to do it myself. But I had one fellow on the back side that was helping me out and taking the weight of the hose. I can tell you the man lift is not a good platform because small movement is really kind of jerky. It's not very stable. So in the field, you got to have for this kind of application, you got to have a better, probably, waist. And then we had a little more materials. We said, okay, let's go ahead and maybe do the top portion too. Again, this is a if we had the more material, really, we could have achieved the larger thickness on this particular abutment. I'll show you the other one. The other one, we were able to achieve more thicknesses. So here is the other abutment. This is the first batch actually was a little more runny than I want it to be. You have to be able to really make that adjustment in the field. And this is after a couple of layers. I think we went about the 3 or 4 layers. Now you can see that in this case we were able to really feel the cavity. We were able to achieve more than 1 inch thickness in some locations. And these are some photos. So you can really achieve, but there is a certain sequence that you have to go through, but you can achieve really even up to, I believe, 1.5, 2 inches of thickness, fairly easy. This is some other, just a photo of the areas. And then we decided to, with the curing compound, I got the name of the curing compound from Ben Grable. I sent him an email. I said, Ben, how do you guys cure these things? And I think he suggested the same thing that they do for the bridge deck overlay. So we use that. And then we were kind of conservative. So we put a wet burlap. I asked them to put a wet burlap. You don't need that. And then plastic sheet, just to be conservative. Now, I'm going to be fairly brief. We have received some funding from the Department of Commerce to commercialize the UHPC Shotcrete and also conduct some workshop. So we are planning to do that, basically conduct some workshop and also commercialize this technology. It is ready to go, and this concept, thanks to the Virginia DOT, that provided really the opportunity to showcase that this thing is feasible. So if you are interested to attend the workshop, that I think it's going to be probably about 4 or 5 months. If you are interested, send me an email. Now, let me go quickly on the lessons learned. Shotcrete with UHPC, like I said, you should be looking at like a system. It is important the staff to be trained. Field personnel must have a specific responsibility. So whoever you have in the field, it's got to have a specific responsibility to reduce the number of people. Of course, one person have to be really watching the entire operation. Cleaning the equipment is very important. This material sets fast. It could ruin your pump. It could ruin your hose, nozzle, everything. So you got to have very clear plan on cleaning up, and because those steel fibers really can ruin everything. It is important to have a practice trial. You need to have large mixer, and you need to have maybe 2 large mixers. So you have basically, so continuously you can feed the pump. Continuously feeding the pump with the UHPC is extremely important. Open source UHPC must be modified for the Shotcrete. If you have experience with the small batches in your laboratory, just expect that you are going to have a different basically characteristic of the same mix using a larger mixer in the field. Large Shotcrete thicknesses can be achieved. In this case, we achieved probably, I think in some places, I'm pretty sure more than 1 inch, but you can go like 1.5, 2 inches, but you have to wait. Between the layers, you got to wait a little bit. The concrete, it's just a couple of minutes, 2-3 minutes between the layers, you can get to a large thickness. You do need to have a contingency plan for some of the equipment that may get damaged. For example, nozzle, hoses, even some aspects of the pump. When you apply this thing, man lift is not a good option because it's just too, you cannot move across the width. You cannot, when you move up and down, it's jerky. So and the weight of the hose it's difficult. you have to make sure that you know that, for example, where the hose is, well, how much head you have, how much you can pump it. So finally, really, Shotcrete with UHPC is very much possible. It's not a difficult task. The only thing is that you have to approach it as a system. You have to be trained. You have to have a staff that are well familiar with the process. And finally, basically the funding. There was no funding provided to us by the Virginia DOT directly, but they did provide basically the help on the site, and also they did provide the mixer and the air compressor, and the staff was extremely helpful. So we truly appreciate. So we appreciate the really the help provided to us and the opportunity. VDOT, especially Sam Flaha, that has been really. I've known Sam for a long time, and he's one of those engineers that's open-minded, interested in some new technologies. Okay. And finally, the opinions and everything that I showed is not really necessarily reflecting the opinion of our sponsor, which is US DOT and the US Army Corps. Again, if you are interested in attending those workshops, please, by all means, send me an email. So I think I wanted to leave some time for questions. So Kathy, I'm done.
Thank you, Torad. Paul, are you ready to help with the question and answer?
I am. Can
Wonderful.
you hear me?
Thank you. If the presenters would please turn their cameras on.
Okay, we did get a number of questions, Torrid and Sam. First ones, these came in beforehand. It said, did the owner check if corrosion had already initiated in the rebar reinforcement? And if yes, what, if anything, was done to remedy the corrosion?
Oh, you're mute, Sam.
Thank you. The corrosion was evident in the pictures, and once you remove, even without removing the concrete, yes, corrosion initiated. What, if anything, was done? In this case, nothing was done. However, one is that we know that the concrete, the UHPC, is impermeable, and therefore that in itself would arrest corrosion. At the same time, there was a discussion early on whether to use anodes in the concrete to help arrest further corrosion. But since this is a test situation and proof of concept, we really did not apply it. But it was considered. And I believe that UHPC, being the impermeable, is essential in those considerations.
Okay. Could you comment on the bonding characteristics between conventional concrete and UHPC?
I will leave that to Dr. Azizi. We haven't done any testing, but I would like him to comment on that. I know that the sounding of the concrete was of the finished product sounded very well, but I'll let him because he did some testing.
Yeah, the bonding is perfect. I mean, it's not that we didn't do any test on this particular shoe, but we've done lots of testing on a Shotcrete at the university, and it's perfect. There's no problem.
Okay. How does the UHPC compare to durable or other high performance concrete?
I can maybe take on that one. I was involved in the back, actually, when me and Sam were in the Nebraska Department of Roads at that time, or Nebraska Department of Transportation now. We were involved with the development of the high strength concrete, high performance concrete later on. And especially when you use with the high performance concrete, because you use the maximum aggregate size, I mean, it could be ½ inches or so. And in the case of the UHPC, it's a very compact, it's a sand. So the durability, I think, durability of the UHPC outperforms the durability of the high performance concrete. Now, maybe Ben or somebody else, maybe Eugene, can also elaborate on that. But I don't believe we have any cementitious material that reaches the durability of the UHPC.
Okay. Is the upfront cost of UHPC higher than normal concrete patchwork?
Let me comment on that. Yes, UHPC has higher cost than typical concrete or even some of the higher performance concrete. However, it should be taken as a whole, meaning that the project as overall. So when we compare the material cost of one project versus another, on the overall project cost, sometimes the difference disappears and it ends up being less than 1%. So in this case and in this application, when you compare the overall cost, let's say we were doing the entire project as not just a demonstration or a proof of concept, there would be the cost of the traffic control, there would be the cost of the man and equipment and labor, and so on and so forth. So the material cost is really small percentage. So if you increase it, say, normally, if you increase it even by 50% or 100%, you still within 10-15% of the overall project cost. So yes, it is a factor, but no, it's not a big factor. And the durability and the service life that you get out of the higher durability concrete more than makes up for the additional cost.
Okay. Have there been any studies done to understand and quantify the delamination effects under compressive loads?
The bonding, like I said, the bonding between the UHPC and the normal strength concrete is excellent. It cannot be worse than the tension. Direct tension test, you never fail at the interface.
Okay. Let's see. Shotcrete is typically edged and floated. Can UHPC also be floated for improved finish?
We don't have any data on that one to make a comment, really.
Okay. Sam?
I guess if I may add to that, as the UHPC applied, it leaves the surface that you can apply other, if you continue the application and use, let's say, a grout of some sort, then you can finish it, because by then the fiber has been covered, because when you finish it, it isn't. But after the fact, even you can go out and finish it whichever way you wish.
Okay. What is the slump range value for sprayable UHPC?
What is that?
Pardon?
What was the question? What is the cost?
What is the slump range value?
Oh, that's a good question.
For sprayable UHPC.
The flow diameter for we try to be around the 6-7 inches.
Okay. And then what is the spray stable thickness?
The spray, like on that video that I showed, is extremely stable. We didn't have, in fact, the second batch that we made, we were spraying, there was no drippage at all. So it performed very well. One of the most challenging things I can say is that the moisture content of the sand and the field, because when you make a large mix and you take the sand for the open, so it's not completely dry. Depending on where you take the sand, from the bottom of the pile or the middle or the surface or the top, you get a different moisture content, and you cannot really subtract exact amount of the water that you should. That's why you have to be able to adjust the mix on site, and that's one of the things that we do.
Okay. The question came in. It says, how common is UHPC shotcrete being used in practice? Is this the first one?
Yeah, I would say the comments that I have heard is that this is believed. We are saying that this is believed to be the first application of the UHPC shotcrete in the field. Now, in the laboratory has been done. I know that in Europe, I think in the Europe, some proprietary material specific for the UHPC has been done by some companies, especially for the culvert. There is a publication by FHWA recently that cites some, I think, field application in the Europe, but I believe in the US, I could be wrong, but I was told that this one was believed to be the first application that was done successfully in the field. Maybe
Okay.
Ben can elaborate on that later on.
Okay. Can you recoat or touch up a shotcrete surface?
I think it's doable, but we haven't done that, so I cannot really make a comment on that.
I mean, after you put the curing compound on it, I wonder if.
Oh yeah, after curing compound, I don't know. I don't really have a date to say anything.
I guess the curing compound can be washed, right? Pressure washed, and then you can apply another coat and so on. And the surface is enough, have enough roughness to bond.
Yeah. One thing I would say is that, you know, when you cast the UHPC against the normal strength concrete, the roughness of the aggregate allows you to get a perfect bond, and you have to prepare it. Now we have had some other cases, the UHPC shell, to attach it, the fresh UHPC against the hardened UHPC, you almost need a mechanical action because you've got a very smooth surface, and we have some data not from the shotcrete, but we've got some data from a beam test that you do not get a good bond between a cast in a fresh UHPC against the hardened UHPC. The only way is to have a mechanical action. So you will not. My gut feeling is that I don't believe you will get a good bonding between fresh UHPC casted against the hardened one, unless you do that before the final setting time of the UHPC that you shotcrete. So if you wait until the UHPC that you have shotcreted, my gut feeling is that you will not get a good bond between the two.
Okay. We're still getting questions coming in, and I'm going to ask Rick Liptek to come in and pick up some of these questions that have come in since 11:55. Rick?
Yeah, thanks, Paul. So one of the questions I noticed here was, is there a difference in the mix design of the UHPC for shotcrete versus just regular UHPC?
Yes, there is. We are adding a viscosity modified admixture to it because that helps to reduce the elastic rebounds of it, and also we monitor. We want to make sure that our flow diameter is less than 6-7 inches. So you're fighting two things really. One is a flowability through the hose, and also being able to shotcrete. So, but you go more than 8 inches, then you shotcrete, and then you see that basically it's just things are dripping. But if you stay between 6 inches or 7, I think it's workable. But it's that's why you got to be the most critical item really is the moisture content of the sand. So the way we do that, let's say for example, if we know that I'm going to add, let's say, so many pounds of water, let's say, we don't add all the waters. We keep some of the waters out, and physically we just look at visually. I mean, it sounds funny, but we usually just look at the mix and then just make sure that, and then there are some indication that how the UHPC is touching the sides of the mixer, and then based on that we decide. And you have to wait. You have to be patient. I think Kathy said the magic happens if you're not too anxious to add more water, and that's true. You just have to be patient a little bit, and then then see how the mix is. So, and that's what Sam was saying to that field adjustment of the mix, I mean, it's important. That's one of the reasons why UHPC with Shotcrete, I mean, a little bit challenging. It's doable, okay?
So given all this work that you've done on this stuff so far, is there a future workshop for Shotcrete technology, either online or offline, that's gonna follow up in the future?
Actually, we out of the Department of Commerce funding, there was they provided the Miami-Dade $19.5 million. Now the copies of my presentation will be in a week or a couple of weeks on our website. Out of the $19.5 million, $1.5 million was provided to us to commercialize the UHPC Shotcrete, but also conduct training workshop. And one of the things that that $1.5 million funding is included is to build a trailer where you have everything you need to go to a job site and do a shotcrete. This includes the silos, this includes the pump, air compressor, even the hydro demolition equipment, hoses, computers, everything. So everything housed in one. The idea of that trailer is to more on the demonstration side, but it can be used also for the basic actual job. We are expecting that probably that trailer will be ready probably in 8 months or so. But there will be a workshop. So if those who are interested, really, they can send me an email. My email is there. So, but we will be conducting a workshop. We may look at the maybe online version of it too. We'll see.
It may have been mentioned in your presentation, one of yous, but what's the percent rebound that kind of comes back off when you shotcrete? There's a certain amount that comes back off, and I
yes. Let me show you something that. And give me just 1 minute. Let me. This is a. I don't know if you guys can see it, but there is no rebound in this case.
So the material was so sticky that it just stayed right there and didn't.
Yeah, if you make the material in this case, I mean, this plate, you see that you don't see any drip.
Yeah, the fibers probably also help kind of keep things tight.
Exactly. So the second batch that we had on the abutment that was supposed to be for practice, this one was on a Wednesday night. It was excellent. That's why I'm saying that you can. The thing is that you have to go like a one layer. You have to put the nozzle back in the pump, but because continuously the UHPC have to run. If you stop, you're done. And then wait for a few minutes, and that sets the one layer, and then you can go back. That's why I'm saying that you can go any kind of thicknesses that you want with this thing, but you have to be between the layers. You got to stop.
Yeah. Okay. Well, there's a couple really long questions that with several parts to them that I'm not sure if I can decipher exactly what they're trying to get at. But so how to improve flexural strength of UHPC for structural element designs? I guess that's maybe I don't know whether the shotcrete, this part of the presentation really applies to that, but there is obviously flexure in some of these elements that you're trying to shotcrete. And I guess, is there any concern about differential, properties, I guess, between the two?
We have done some. I think Ben probably in his module is going to talk about the flexural strength, but we have some beams that we have shotcreted. You're looking at. We don't have the test yet. We have shotcreted, and then we are going to put under the basically apply a 3-point loading, trying to see that how the bond between the shotcrete and the beam stays on. But I don't have the data.
Okay. Well, with that, I guess, Kathy, we probably can move on to the next module.
Sounds great.
You haven't given me the hook here, so I'm, you know,
We're doing really well on time. So,
all right, good.
One thing that I did want to remind everyone is that we do have the Shotcrete workshop at the World Bridge Engineering Conference in Miami in December. So I believe that's on the night of December 12th. So just a reminder that there is that opportunity. All right, I'm going to share my screen. Great. All right. So thank you very much to Paul and Rick for helping with the question and answer. And thank you to Sam and Atorad for presenting on Module 1. The work you've done in Virginia, it's really going to advance our industry and our ability to do preservation and rehabilitation of our aging infrastructure. So thank you for your work there.